Bismillahirrahmanirrahim. How are you, students? I hope you are fine. Students, this is going to be another lecture on the series of online classes for the students of class 7. In this lecture, I have solved some problems related to your textbook. That's why I named this lecture Question Solutions. So without further delay, let's get started. Okay, here are two sides A and B, and an angle B is given. Okay, I have taken the first question from the homework of the previous lecture, as many of you asked me what is the correct answer. Okay, if three angles of a triangle are given, can you draw a specific triangle? So I will solve this one on your demand. Next question is, you need to draw your triangle when angle B is included in between A and B. And the third question is, draw a triangle whose one side is 2A and the opposite side of angle B is small b. Students, this one is going to be very important and we will spend a lot of time with question C. So let us start the solution. But before we begin, I want you to write down the questions in your copy and then see the answers. The answer to the first question is no, you cannot draw a specific triangle if you have only the three angles given. Okay? Suppose there are three angles, 60 degree, 60 degree and 60 degree respectively. Say they are given. See the picture below. The triangle has side length of AB 10 centimeters. And each and every angle is 60 degree. Okay, well, that makes it an equilateral triangle with every side of 10 centimeter and each angle is 60 degrees. Now if you change the side length of AB to 15 centimeter, then you will actually get another equilateral triangle which is bigger in size. Still, each and every angle of that big triangle is also 60 degrees. You see that big one, each and every angle is 60 degrees. So by changing the length of AB, we can actually make millions of triangles with each and every angle 60 degree. Hence, you cannot form a unique triangle only with three angles given. I hope you understand this. Okay. Well, this slide is going to be very easy, as I have showed you how you can construct a triangle if you have two sides and an included angle. And in question B, you have two sides A and B, and the included angle in between AB is 30 degree given. Here is your first side A, your second side B, and the angle in between AB is angle B. So firstly, we cut off BC equal to 3 centimeters from any ray BD. Okay, here you can see. In the second step, we draw an angle equal to angle B at point B. As you can see, that one. And in the third step, we cut off BA equal to B from BA. You can see. Now just connect A with C to draw your triangle. You can see it from the picture that A below, BC is A and BA is B, and the angle in between AB is B there. So ABC is your required triangle. That one is easy, right? Now let us solve the tough one. Oh, remember our question was with two sides AB and an angle B, and in question C we need to draw a triangle when side B is opposite to angle B. Small b is opposite to angle B. That means we have two sides and one angle opposite to the smaller side B. As B is 4 centimeter and 2A is 6 centimeters. Okay. So what we actually need to do, we need to draw that triangle with opposite to the smaller side B. The angle is opposite to the smaller side. Keep this in mind, as I am going to change this question a little bit in a while. Okay. Now first, in order to solve this, I want you to see these statements first. Okay, can you solve question C with the statement 1? Statement 1 is length of the three sides, as it is concerned with three sides. So question 1 cannot be solved with this one, as question C is a little bit different. Okay, so it is ruled out. Again, you cannot solve question C by statement 2, as angle B is not the included angle, but rather it is an opposite angle to the smaller side. So it is also ruled out. What about statement 3? The size of two angles and their adjacent side. We do not have two angles in our question, so it is also ruled out. Here you can see this statement deals with an opposite side. I mean, do you think it is sufficient to solve question C? Let us see the question again. Draw a triangle whose one side is 2A and the opposite side of angle B is small b. Okay. So this statement is also ruled out. Now, what about that one? The size of two sides on one opposite angle. Yes, we got it. We got our statement with which is similar to our statement. Okay. So 2A and B are our sides, and angle B is the opposite to one of these sides. So that's the statement we need. Okay. And you should also remember that I did not solve this statement in our previous lecture. I actually gave this one as a homework. So let us see this into action to solve question C. Okay. Here is our question. Here we have two sides B and 2A, and the angle B, remember that angle B is opposite to side small b. Okay. Here are our sides and angle. Well, that angle B, remember that this one is opposite to the smaller side B. Well, in first step, we draw an angle equal to angle B at point B of the line BD. Well, that line BD, and here we actually made an angle equal to that angle B. Okay. Then after that, we have actually cut a segment BA from B with equal to 2A. So here it is. Okay. Now there is actually a trick after that. Place your compass at A, and with radius equal to the opposite side, remember the radius equal to the opposite side, we draw an arc. Here is opposite side is B, so with radius equals to B, we draw an arc from point A. You see that? And you can see the arc intersects BD at C and C prime respectively. You can see that. Okay. Then just connect A with C and A with C prime to complete your construction. Here you can easily see that ABC and ABC prime, well, there are actually two triangles with the given condition can be built up. Okay. Now what you need to remember in this case, that I have drawn the arc AC or AC prime with equal radius of the opposite side. Well, the arc radius is the opposite side. Opposite side is the arc radius. Remember that. As I'm going to change this question a little bit more in the next slide. Okay. Now in this slide I have actually changed the question a little bit more. This time angle B is the opposite angle of the side 2A, not B. Now I suggest you to draw this by your own. So pause the video and solve it, and when you are done, come back here to start it again. Let us start the drawing by an arbitrary line, say this line. Okay. And at the bottom left I draw an angle equal to angle B. As you can see, now I actually repeated the process as previous. Actually you can see now that the arc radius 2A is very big compared to B, so that's why actually this arc does not intersect that line. By the way, it will intersect that line if you actually extend that line forward and backward, but in that case the triangle will be a weird kind of triangle. So instead of doing this, I'm going to show you another very easy way to do this if the angle is opposite to the bigger side. Now what we do actually, from any ray BD, we actually cut off BC portion with equal length of B. Then we actually construct an angle equal to B at point B. Now place your compass at C. Okay, open it up to 2A and then mark an arc. Mark an arc from C with your compass. Mark an arc with that radius is 2A, and actually that hits the above line at A. So just connect A with C, then this is your triangle. and ABC is your required triangle, because you can see that angle B, the opposite to that angle is 2A. As you can see from the picture, it is clear that 2A is the opposite of that one, and a small b is also there, so that makes ABC your required triangle. That means this statement can be solved in two ways. If the side opposite to your angle, if it is smaller, then you do that way, and if it is bigger, then if you do in that way, the right one, as I have solved here. Okay, so if you are given two sides and an angle opposite to one of them, you should do either of the two. Now let us see the homework that I actually provided you in the last lecture. Well, if you are given three angles of a triangle, can you draw a specific triangle? If not, explain it. Well, I have explained it. And question B, draw an angle equal to angle B. You can see that angle B is a right angle. Well, I just want you to draw a right angle, and you all know how to draw right angles, so I'm not going to explain B. What I want to explain here, draw a right angle triangle whose hypotenuse is 2 cm larger than that of the drawn triangle and an angle equal to ACB. Well, many of you asked me that how to solve this one. So let us crack this. Here is your angle. Because you need to draw a right angle, so I have taken the right angle as X. Okay, there is another triangle ACB, and that A is the length of the hypotenuse. In this case, it is 9 centimeters. So let us see this. So to accurately construct a triangle, you need to know, you all know that you need to know all of them. Okay, now do tell me if the length of the three sides are given, then can you of course can draw a triangle, but in this case it is ruled out because we are given two angles and an opposite side. Well, that hypotenuse is the opposite side of the right angle, so that is why I call it an opposite side. The length of two sides and an included angle, well, that one is not included angle, so this is also ruled out. And similarly, the size of two angles and the adjacent side, well, hypotenuse is not the adjacent side, though this one is also ruled out. Well, that one makes sense. Okay, the size of two angles and one opposite side. As you can see, the size of two angles and one opposite side, well, this suffices to solve this one. Your two angles are angle X and angle ACB, and the opposite side is A, and that opposite side is opposite of that angle X. So what we do here, actually I have solved this type of question in the previous lecture, so I suggest you to see those first and then come here to see that one. Okay, now from any ray PS, I'm going to cut PQ equals to A, the length of hypotenuse. Then at point P, I'm going to create that angle ACB. Okay, QPM is actually equals to ACB. Well, I'm going to create at point Q again that angle ACB. Okay, you can see that that angle ACB is created again. Okay, so QPM and SQN, they are same. As I have shown you in the previous lecture, well, this one is solved in the previous lecture. Okay, now at point Q, you draw an angle equal to angle X, that means the right angle. Okay, at point Q, we're going to create that one. Okay, well, now, well, as you can see, QN and PM, they are parallel. So that's why that angle PRQ is equal to RQN. You can see that one. So now, have your attention to the picture. Well, PQ is the required triangle. Do you think so? If you think so, let me know. And I guarantee you PQR is your required triangle. You see, that one is not that complicated. Well, I don't know how you people call it complicated. Many of you actually asked me about the solution of this question. Here is the solution. By the way, do not forget to write the steps. Well, I actually skipped that to make that lecture small. Okay, let us solve some MCQ type questions. Well, I call it MCQ, but this is not MCQ type question in your exercise, as I am going to solve exercise 9.1 from now. Well, this is a picture ABC. You can see that angle B is right angle and BDC is also a right angle. Okay, determine the value of ABD, CBD and ADB. We'll first determine the third one first, because you can see that BD is perpendicular to AC, so ADB is 90 degree. It is obvious from the picture. Let us go for the first one. In triangle ABD, you know the sum of the angles of a triangle always 180 degrees. So ABD, ADB plus BAD is 180 degrees. And now you know ADB is 90 degrees, right? ADB is 90 degrees and the angle A is given 48 degrees. That means BAD is also 48 degrees. So ABD is 90 angle ABD plus 90 plus 48 equals to 180 degrees. That's why angle ABD is 42 degrees. Well, this is question 1 of your exercise book 9.1. Let us find the second one, CBD. Now look at the picture carefully, that CBD. Look at the angle ABC. This one is a right angle. So we can actually tell that ABD plus CBD is actually 90 degrees, right? You see, ABD plus CBD is 90 degrees and we need to find CBD. As you can see, ABD from the previous line is 42 degrees. We have solved it, right? So CBD is 90 minus 42 is 48 degrees. Okay, that question is done. Okay, let us see the second question. The vertical angle of an isosceles triangle is 50 degrees. Okay, the vertical angle of an isosceles triangle is 50 degrees. Find the other two angles. Okay, now as you all know, the base angles of an isosceles triangle are always equal. So I actually named that two angles X and X as they are base angles and they are equal. And you all know the sum of the angles of a triangle are always 180 degrees. So let us solve this one. Angle X plus 50 degree is 180 degree. As if you add the angles of a triangle, it will always be 180 degrees. So if you calculate it, then X is actually equals to 130 over 2 is 65 degrees. Or let me know in the comment section if you do not understand this, okay? Now let us go for the third question. Prove that the sum of the angles of a quadrilateral is 4 right angles. Well, this one is a little bit important theorem, okay? But this one is so easy. I have taken this from exercise 9.1, as some of you actually suggested me to create a lecture on an exercise 9.1. Okay. Suppose ABCD is a quadrilateral and we need to prove that angle A, angle B, angle C, angle D, if we add up those 4 angles, and it would be 4 right angles. Okay. Now we just join B and D. Okay. Now in triangle ABD, the upper portion of the diagonal ABD, if we add up the angles, suppose angle A plus angle ABD plus angle ADB, it is actually 2 right angles. 180 means 2 right angles, right? In a similar way, the triangle below the diagonal, see in the picture that in triangle BDC, you can do that thing again. So in triangle BDC, actually angle C plus CBD plus CDB, actually 2 right angles. What we will do, actually we will add those equation 1 and equation 2. Then let us see what happens. Okay, in the next slide, let us add those equations. Actually, I have added them. Angle A plus angle C plus angle ABD plus CBD plus ADB plus CDB equals to 2 right angles plus 2 right angles, actually is equal to 4 right angles. Now look very carefully in the picture. The angle B can be written as ABD plus CBD, as I have marked them in yellow color. Again, on the left of the picture, ADB plus CDB can be written as angle D. So as you can see, ADB plus CDB equal to ADC or angle D. So from equation 3, just substitute those values, angle A plus angle C plus angle B plus angle D equal to 4 right angles. Hence the proof is complete. By the way, do not forget to write the justification part. You all know what is called the justification part, okay? Let us see our final question of this lecture. Well, there is actually, this is also taken from exercise 9.1, question number 4. Here are actually 2 lines PQ and RS, and L, F are 2 points on PQ, and you can see from the picture ME are 2 points on RS. What we need to do here, that if I draw two perpendicular lines from PQ to RS, then that means LM and EF. Actually, that LMO equal to 90 degree and EFO is 90 degree from the picture. Well, this one is tough, so draw your utmost attention here and write it down. Okay, so let us see this into action. You can see that LMO and EFO, they are 90 degree from the picture, and EOF and LOM, they are same. You tell me why they are same in quantity. Because they are vertically opposite angles. So easy, right? Now in triangle OEF on my left, if I add the angles of the triangle, it would be 180 degree. That means EFO EOF plus OEF equal to 180 degrees. Similarly, what we can do from that above triangle, OLM, actually OLM plus LOM plus LMO equal to 180 degrees. As you can see in equation 1 and equation 2, they both are equal to 180 degrees. So the quantities in the left side, they must be equal, as they are equal to 180 degrees. So let us put an equal sign in between them. You can see EFO plus EOF plus OEF equals to OLM plus LOM plus LMO. Okay, now you can see that EOF and LOM are same, okay, as they are vertically opposite angles. So we can delete those two. Okay, now what we have is this one. Now again, you can see that EFO and LMO, okay, they are 90 degrees, so we can actually delete those two also. So that's actually take us to OEF equals to OLM. Hence the proof is done. Well, by the way, I did not mention the question first, because well, if I had mentioned the question, well, the question is so tricky, but the proof is not that one. So I suggest you to see the question first. From your textbook, your question was to prove that those two angles OEF and OLM, are they equal or not. So the proof is done. Okay. Okay, the lecture is complete here. Now here is your homework. The length of a side and two of its adjoining angles are given. Construct the triangle. In that case, when the side is 5 centimeters and two angles are 30, 45. And similarly, you should do that one also. Well, I have taken those from your book. Tell me if you can solve them. Again, that one is another question. Solve this one also, and that one, the creative question. Well, in that creative question, A is very important. I want all of you to solve this one by your own or by discussing with your friends. In order to draw a unique triangle, which of the statements are sufficient? This one is the most important questions of all. Okay, well, this question, if you are able to solve this question, well, that means you are understanding triangles. Okay, it's very important. I want you to immediately solve this question. And to solve this question, I want you to go through your examples. Go through the 6 examples from your book and the exercise MCQs and my lecture and my 2 lectures. Then I think you will be able to answer that question. It's very important, and you should let me know in the comment section that if you understand that number A question or not. And in C, draw such a right angle triangle so that the two sides adjacent to the right angles are equal to A and B. Well, these things actually seems homework. Well, don't think that I did not solve all of them. Actually, I solved the process of that relates these homeworks. All of them are solved. So try to find, say for example, 5 centimeter, 30 degree and 45 degree, which statement can solve this one and which statement can solve this one, and you will find your answer. I hope you enjoyed this lecture. By the way, this one a little bit tricky. So if you read this lecture through again and again, then I think you will get this lecture. Otherwise, there is no way you will get triangles. I hope you enjoyed. Thank you.